And on the back, there is 2.1 about domain and range. I don't know if I'm going to put domain and range on the quiz tomorrow, but I am going to put a math modeling problem on the quiz tomorrow. But if you did very well on those, obviously you don't have to do the retake on the quiz tomorrow. So it's up to you whether you want to do the second, actually it's the third one, right, review for the quiz tomorrow. The two new ones, the two new sections on the quiz tomorrow, the solving quadratics by factoring, solving by factoring, and then solving by square rooting. Those are new sections that you're going to have to do on the quiz tomorrow, right? So these you have to do. In fact, it'll be on your homework check, both of these reviews. Okay, and don't forget, I'm going to Thursday probably put in Delta Math formative grade, which many of you blew off last Friday. Many of you. You might want to think about getting that done over this holiday weekend that you guys have. Okay. I will be putting in zeros for those probably Thursday, but if you finish it over the weekend, past Thursday, please send me an email telling me that you finished it, and I will change your zero to whatever grade you got. All right. Questions, comments, concerns? Yes, ma'am. Yes, you may use the restroom. And again, it seems like this half of the classroom is here today. It's so weird. All right, let's start out by doing number 9. Everybody picked up the worksheets as they came into the classroom? All right, number 9. Again, the two things that you can use on your quiz tomorrow is the little blue note card and the factoring flow chart. Could have swore I printed some out. Yep, that blue little card and I do have a couple. I'll print some more out. The factoring flow chart. So if anybody wants a flow chart and needs one, I'll put them. Okay, and the blue cards are up there. In fact, I'll put them on that card. How about that? One chart for all. So these two you can always use on the quizzes. And I would even go as far as to add, I would add some perfect squares to this all the way up to 20. Right now it's at 15. Okay, 225 is 15 squared. I would go up to 20. I would just do it. Yeah, yesterday I did the first review. This is actually the second review. Second review, and then the retakes. Okay. So let's go ahead and do number 9 on the second review. And if I look at my flow chart, the first thing it says is, can I take out any common terms? Well, can I? Yes, I can. I can take out, let's see, I have the numbers 40 and 32. What's the largest factor of both 40 and 32? 4 is a factor of both. 8 is the largest one, right? Okay. If you did 4, I mean, you would end up with, let's see, 10 and 8. So you have another 2 in there that you could do. 10x plus or minus 8. You would have another 2 in there. Okay, so if you pull out a 2, that gives you your 8. And I can take out one of the x's, right? This has 2 x's, this has 1 x. So 40 divided by 8 is 5. X squared divided by x to the first is x. 32 divided by 8 is 4. And x to the first divided by x to the first is just 1, so 4 times 1 is 4. Set each one of these factors equal to 0. 8x equals 0, or 5x minus 4 equals 0. Let's see, I'm going to divide by 8 on this one. So x equals 0. And then this one, I'm going to add 4 to both sides. So I get 5x equal 4. Then divide by 5. And I get x equal 4/5. Okay, this is your answer. You can leave it like that. Personally, I like doing the short answer, x equals 0, comma 4/5. Either one is fine though. Okay, looking at number 11, can I factor out any terms? Nope. What type of polynomial do I have? It's a binomial, 2 terms. Is it a difference of squares? If you look at your squares, let's see, there's a 4 and a 9. 4 and a 9. So yes, it is a difference of squares. So I'm going to write it as a difference of squares. 2 squared n squared minus 3 squared equals 0. And now I can use my shortcut formula, right? The base 2n plus the base 3 times the quantity, the base 2n minus the base 3. Now I'm just going to solve for one of these because the other one's just going to be the opposite of the sign. So I'm going to take 2n plus 3, set it equal to 0. Let's see, minus 3 minus 3. I get 2n equals 0 minus 3 is minus 3. Divide by 2. Divide by 2. And this n is going to equal negative 3 halves. And my other answer is going to be a positive 3 halves, right? Well, I'm going to use my short symbolization, right? Plus or minus 3 halves. So there's my answer. So that's solving quadratic equations by factoring. And the other new concept we did was solving quadratic equations by taking the square roots. To do that, we have to have the variable by itself. In 13 we do. So I'm going to go ahead and just take the square root of both sides. It's going to cancel out my power of 2. So I'm going to get r equal, don't forget we have to do the plus or minus, square root of 96. Now, most of you are going to get, hey, I got the answer, and I'm going to go to the next problem. But did you check to see if 96 can be simplified? Is there a factor of 96 that's a perfect square? And yesterday, I showed you guys a little shortcut. Just a little bit, right? Still kind of complicated, but what I did was I took 96, I divided it by 2. Let's see, 96 divided by 2 gives me 48, right? So my perfect squares, I'm going to write them down. You have them on that chart. So 1 squared is 1, 2 squared is 4, 9, 16, 25, 36, 49. So after I divided it by 2, I'm going to start with the next lowest perfect square, which is 36. So I'm going to take 96 and start dividing it by those perfect squares. So 96 divided by 36 gives me a decimal, so 36 doesn't work. I'm going to try 25. I know 25 is not going to work because it has to be an even number, right? Well, not even, but a multiple of 25. 96 is not a multiple of 25. I'm going to try 16. 96 divided by 16. And I get a whole number 6. So I know that 16, a perfect square, is a factor of 96. So I'm going to rewrite this as r equals plus or minus square root of my perfect square, which is 16, times the square root of 6. And simplify the square root of 16. So r is going to equal plus or minus 4, good, square root of 6. So while it's still a little bit of a process, it's not that bad. It's better than writing out all the factors of 96, and hopefully you don't miss one. Okay, questions? All right, 15. 15, before I square root and get rid of the power 2, I have to get rid of that 4 being multiplied to the quantity k minus 3. So I'm going to undo multiplication of 4 by dividing by 4. Got to do it to both sides. And I get the quantity k minus 3 squared equals 3. 12 divided by 4 is 3. Now I can take the square root. Square root cancels out the power 2. Now there's no mathematical operations going on with the k minus 3. I can drop the parentheses. Don't forget the plus or minus for the square root of 3. Have to get k by itself, so I'm going to add 3 to both sides. So I get k. These are unlike terms. Put the number first, then your radical. 3 plus or minus square root of 3. And that's my answer. Questions, comments, concerns? $14. $14, you would have to get this term by itself first. So start by subtracting 5 and go from there. Okay. Any other questions? All right, now I'm gonna do probably just like, I don't know, maybe problem number 1 here. This is a retake on tomorrow's quiz, quadratic modeling. I had quite a few requests for this. All right, so what we're going to do is Maya shoots an arrow upward. In fact, this is pretty much the same problem that was on the quiz. I just changed a couple of numbers here. So Maya shoots an arrow upward. The height h of t of the arrow t seconds later is given by the equation h of t equals negative 16, which is your constant for gravity, right? Negative 16t squared plus 115t plus 5, where t is time. So the first thing I'm going to do is draw my little graph, my sketch. I always highlight the first quadrant because that's where all the action happens, right? Instead of y, I use h for height. Instead of x, I use t for time. Okay, my initial height here is 5 feet, so I'm starting at 5 feet, and I don't think that's going to make too much difference in our problem, but all right, so Maya shoots this arrow upwards, and then it comes back down to Earth and hits the ground. And these problems, we're really interested in the vertex and in this case, the t-intercept, because we're not using x. So my vertex here, it's not xh, it's th, right? My height is h, my y, what would be my y, and then my t is the time it gets to the maximum height. That would be my t. And then we're always interested in this 0. Your calculator calls it a 0 because that's when my h equals 0. It's the x-intercept, or in this case, the t-intercept. So there's everything that I need to know. Okay, to put this in your calculators, I'm going to check my calculator because, again, this classroom has statistical students in here. So the first thing you want to do is hit your y equals button, clear everything out of there, make sure your plots are off. If they're on, they'll be highlighted. Okay? That means the statistical plotting is on. So you have to move your cursor over there, turn them off, and then that way we'll be able to use it for algebra. Then go to your zoom key, put your chart, your graph back to standard default negative 10 to 10, and for the x and y axis. Then go back and start putting your equation in. Okay? So y equals, and again, use the negative key for the negative 16. I still have a couple of students using the minus key. You have to use the negative key. 16, I'm using x instead of t. X squared plus 115x plus 5. Now when we go to graph this, our parabola is going to be way off our calculator here, okay? Because of that big number for the bx term, for the middle term. This, if it was our c term, we could probably put in 120 and graph it, but it gets exponentially larger here. Okay? So I'm going to at least double this, probably even go to like 300. So I'm going to go to my window. For my y max, My Y max, I'm going to put at 300 and see what happens. Graph it. And actually, that's pretty good. Okay. And again, this is all on your blue note card, not the window, but from here on out. If I want to find the maximum this time, okay. Oh, actually, adjusting the window is. To find the maximum, I'm going to hit second trace. Second trace. Oh, I'm sorry, wrong one. Brings up my calculate window. Okay. And I want to find the maximum, which is number 4. And it's asking me to put a left bound in there and a right bound. So I'm going to go ahead and put a left bound in there. Anywhere to the left, any of these points to the left of that maximum will work. Hit enter. Then get to the right of that maximum point. Hit enter. And then enter again, and it will tell me what the vertex is. My vertex is 3.6, comma 211.6. And again, this is my time, and this is my height, maximum height. So what is the maximum height? It's 211.6 feet at 3.6 seconds. Okay, when does it hit the ground? Well, this is where I got to calculate for that t-intercept at 0. So I'm going to go back to my calculate menu, second trace. This time I want the 0, enter. And again, anywhere to the left of this point, which I'm at, I could even hit enter now. I'm going to get a little closer. Going to hit enter. Now I have to get to the other side of the x-axis, anywhere. Hit enter. And then enter again. And it gives me the t-intercept is going to be 7.2, 0. Now, your calculator, well, this one did anyway, it's got a value here for my 0, 1e to the negative 11. That's your calculator saying, hey, y equals 0. It's just giving you, trying to give you an exact number for the pixels it has. Whenever you get something like e to the negative 11, that's 0. Okay. So my object hits the ground at, again, that's my t-intercept, 7.2 seconds. Now, the table is the easiest part you can fill out here. Okay? You go to your table, and what we're going to do is we're going to hit the second button and the graph button. It brings up our table. Well, they give you the x values or the t values. See, at 2, they want us the y value. So my 2 is 171 feet. My 3 is 206 feet. And my 4 is 209 feet. And the last thing we have to do is find the average rate of change. Now, we have to use the average rate of change because we have a parabola here. It's not a constant slope. Otherwise, we'd say, hey, find the slope. But it's an inconsistent slope, so therefore we have to find the average rate of change. And instead of delta y, we're going to use delta h over delta, instead of delta x, delta t. In other words, y2 minus y1 over x2 minus x1. All right, they give us, remember that's the independent, they give us t2, so x2 minus x1 is 3. The height for 2 was 171, minus the height for 3 is 206. See, 171 minus 206, negative 35, over 2 minus 3, negative 1. So the average rate of change is 35 feet per second. And that is quadratic modeling. Isn't that fun? All right. I will post this stuff on Google Classroom. If I were you, if you're retaking the quadratic modeling, do number 2. I'll put the answer key on there. You guys have 4 problems on today's review. You had, 8 problems yesterday on that review. And then I am...
I think I'm set.